All right, we're all set there. I see the slides up. So yeah, this is my name's Adam. I go by he and him, and we're going to talk a little bit about kind of our story at the Northwestern, I guess, dev team, kind of going from or considering IIIF Presentation API version 2 to version 3, and kind of how we've approached that in the past, what we're doing now, and hopefully this is something that might be interesting to other institutions considering a similar transition. So before I jump into kind of frame this out a little bit, I'll let my two coworkers introduce themselves as well. How about Karen, or how about Matt first?
Hi, I'm Matt Jordan. I'm a front-end developer at Northwestern. Only been here about a month. I was previously at University of Tennessee. And my pronouns are he and him.
I am Karen Shaw. I am another software developer on the repository and digital curation team at Northwestern, and my pronouns are she and her.
So I guess just to get started, just to not assume that everyone might be super familiar with IIIF. So we'll just kind of start big picture here. So what exactly is IIIF? So according to the IIIF website, a growing community of the world's leading research libraries and image repositories who are working on a community framework for interoperable image, and now with the advent of 3.0 and media delivery. So IIIF, kind of its core is, it can be thought of as having multiple APIs, which allow web applications to model their data, to serve content, to handle authentication, and more. So you can get a lot more detailed info on the IIIF ecosystem and what some of these APIs do through their website, which we encourage all to do if you're interested. So this graphic here, I think the key takeaway is that when your custom data at your institution in any way, shape, or form you model it, when it conforms to a IIIF API spec, then any application in the world or any UI client could consume and present your data, assuming it's publicly accessible, public rights, and whatnot. So, so maybe like a researcher researching from Africa could explore collections at the University of Hong Kong with mouse clicks, or one could curate their own collection of items referencing public IIIF manifests from institutions across the world. So for this presentation, we are going to focus exclusively just on the presentation API and not some of the other IIIF APIs. The presentation API describes, according to Tom Crane, who's a prominent IIIF spec author, just enough metadata to drive a remote viewing experience. So the presentation API, it's a collection of, I don't know if it's kind of hard to see, a collection of conceptual labels for how to represent an object or a thing of some sort. Version 2 of the spec was developed with representing mostly like image-based content in mind. So these could be items such as books, paintings, sculptures of scary dinosaurs or whatnot. But 3.0 spec begins considering time-based media and beyond, potentially. So this could look like an opera, a movie, an oral history field recording, or maybe even some kind of virtual reality, or who knows what's around the corner. And this is what this presentation is really about, more or less. Our team is fast seeing a world for our collections where they don't necessarily fall into neat silos of a certain type of something. So we're beginning to experiment with multi-canvas IIIF manifest to represent something, say like a, maybe like a Johnny Cash box set or something there, or something similar, which might contain multiple videos. It has images like a picture book. Perhaps there's some, audio interviews with Johnny Cash. Maybe even, in the future, maybe there's a Johnny Cash hologram. Who knows, right? The IIIF 3.0 presentation API is attempting to represent things that we kind of see and interact with in the real world. And our dev team would like, to attempt to emulate this, I guess, multimedia experience for end users of our applications as well.
So to tell the story of our journey to adopting IIIF Presentation 3, we need to rewind back in time to about 2019. So 2 years ago, we had two separate repositories. We had a Hyrax-based image repository and an Avalon instance for our AV materials. We were underway planning and starting to build a new repository system, Meadow, that would house both types of content. We migrated our image content first, which was earlier this year. Our old image repository had previously written IIIF Presentation 2 manifest for the ImageWorks to S3. So the migration in terms of manifest was seamless. Meadow just took over writing the manifest to the same place as our old Hyrax app did. Our publicly accessible manifest and image URLs remained consistent. Our AV content has yet to be migrated. It's slated for later this year. And initially, we were assuming that a move to IIIF version 3 would take place at some point during this migration in order to better support our AV content. But along the way, we decided not to do it, even though there were several points at which the transition would have made sense. So why not? Well, one, the spec is complex and we were moving fast towards launch and migration, and we thought we could switch to version 3 in the future when things were a bit calmer. And also our data model, which we were still in the process of defining, was challenging to map to a manifest. We hadn't made core decisions and didn't until actually after images were migrated about whether, for example, ImageWorks would contain AV content. We were concerned about our existing image manifests. We didn't want to break them. They were in use, possibly and hopefully beyond our own institution. We were concerned about viewer support of the 3.x spec. Our React OpenSeaDragon viewer that we were using would need some work to support v3. We also didn't want to change publicly accessible or publicly available current manifest content or URLs. So in a nutshell, we were thinking about this as a big move from 2 to 3, updating our image manifest and viewer and totally dropping support for 2 altogether. And it was overwhelming to us. So what we decided to do instead was not produce any manifests at all for our AV content. We would just retrieve file set info and metadata, either from Elasticsearch or GraphQL, depending on which of our apps was calling. We'd use an HTML5 video tag as the player, and we would use WebVTT to contain the structure. For anyone not familiar, WebVTT stands for Web Video Text Tracks, is a widely adopted W3C standard for displaying time text in connection with the HTML5 track element. So it's a text-based format that contains structure information like video captions and subtitles or CD tracks. So this approach meant that we had no manifest to offer for public consumption, but we considered this just an iteration on our road to IIIF 3. So rewind back in time to 1 month ago, and then suddenly we abruptly changed our minds and decided to go for it and produce IIIF Pres 3 manifest for our AV content. So what had happened was that we had defined our data model. We had 4 file set roles, access and preservation files. And then we also defined a couple supplementary or a couple additional roles. An auxiliary file set would be like image-based content. So it might be like a CD cover for an audio file. And supplemental content was generally text-based files that could, for example, be vendor-supplied content. So we also defined 3 work types: image, audio, and video, and made a decision that our image works would not contain AV content. So this meant that we could just leave our version 2 manifest in place for our images and continue to use our React viewer for our image type works, but potentially go a different route with audio and video. The prototype HTML5 player that we had built had really helped us start thinking this all through, and we felt much more confident forging ahead with V3. We were also excited to use a common spec rather than going our own way with an ad hoc spec we developed ourselves. And finally, we had a new team member, Matt Jordan, join our team, who really hit the ground running and greatly increased our team knowledge and capacity to do this work. So with that, I will turn it over to Matt.
Hi. Yeah, so right away we decided, or soon after my start, we decided that we would go with Presentation 3 as a model. And one of the first things we needed to do after we did that was define our manifest. This would allow individuals on our team to work towards a common goal independently. And going this route, Adam and I could develop the client, the IIIF client, our AV player that renders our IIIF manifest, and Karen could develop the framework for the Pres 3 manifest generation based upon our work model. And so how did we do that? Well, designing the manifest, we followed a few key steps here. We read the Presentation 3 specs, tried to understand manifests, canvases, annotations and their motivations, content resources within those annotations, and full disclosure, I've been sort of living in Pres 3 land for nearly a year, and I still learn new things all the time. There's a lot to learn out there. And one thing that really helps me is the IIIF cookbook that's available on the IIIF website and in GitHub, and the recipes there. These are like immensely helpful. For one, I believe it was either yesterday or the day before, folks at IU were talking about the IIIF React Media Player, and a lot of my inspiration has come from a recipe that sort of, I think, helped model both that player and this player. And it's been around since earlier this year, and it basically prescribes how one should construct a video or a sound manifest with a supplementing transcript. Following that recipe model, we built upon it, and we wanted to create our own mock manifests. And we sort of sandboxed these, and we just sort of tinkered with the JSON. It helped us understand the spec better and helped us visualize in a client, the IIIF viewer, how it might be rendered. And while we were doing that, we tested these mock manifests in viewers, specifically Mirador 3, and just tried to, before we could build our own viewer, we wanted to see how these manifests might exist in other viewers. And I'm going to hand it back to Karen to discuss how we generated these manifests now that we had a stable mock.
Yeah, so writing the manifest generation code for V3 was fairly quick. We already had most of the infrastructure in place for producing the V2 manifests. We did leverage the online presentation API validator tool quite a bit in trying to ensure that we were producing valid manifests. And then in terms of presentation API version, as I mentioned before, we had decided we're basically going to support both Pres 2 manifests and Pres 3. So we focused on architecting coexisting routes that would allow us to migrate our images to V3 at any point in the future, or to produce both types for images and let clients choose, and also to support other versions possibly in the future.
Okay, and back to the front end. We decided that we needed to sort of refine the problem. And what were we trying to do in the first place? Well, we're building a UI component that represents an AV work. We need this component or viewer to be AV first. We need this component to exist in multiple applications, meaning our Meadow, our repository, and in digital collections, our front end. And we know that our works are complex and may contain multiple time-based file sets that range from video to sound. And then in addition, there might also be some auxiliary images associated with those AV file sets. And that those AV file sets might have corresponding textual content for captions, transcripts, subtitling, and maybe even chapters. Structural data, etc. And finally, we are going to move forward with IIIF 3 presentation, with the 3.0 presentation API as our model. And it allowed us to start development. So zoom forward a few weeks, and here we are. And I'm going to walk through how we brought this manifest to life and how sort of the anatomy of that manifest sort of maps to the different components in our UI or in our player. The first thing we do is we read the manifest items array, and we output all canvases to below that HTML5 video element. And by default, we are setting the first canvas as our active canvas. You sort of see right there in the JSON example, there's a duration and a label. And within those canvases, each of them have an annotation targeting the canvas ID with a motivation of painting. And within that annotation, there's a content resource, that's the body, with a type. And that type here is video. And for our app, we really care about any of these that are video, sound, or image types. Sound and video resources will have an ID that we directly feed to our HTML5 video source attribute in that HTML5 element. And we additionally could have a sound canvas in our manifest, and images. And these are our auxiliary images again, and this is an AV first player, and they're somehow related to the video or sound. And we don't expect this to be a kitchen sink viewer right now, or maybe even ever. So we're just going to render these in a minimal fashion, and deep zoom may come in a future release. Also included in our manifest may be annotations. Really, in Pres 3, almost everything is an annotation. But these annotations have the motivation of supplementing. And really what that means is that a client can optionally display them. In our AV manifest, these will carry a content resource for WebVTT. And we will feed these to our HTML5 video player as the optional tracks right there where the closed captioning button is in the video. element. And we will also pull down that VTT, fetch it, and then parse its keys, and render them to the navigator component that's adjacent to the player. And just a note, to get this project off the ground, keep our manifest lightweight and easy for us to render, we are using WebVTT for structural textual data such as chapters as well as transcripts. There are benefits to perhaps shifting our structural data elsewhere in our manifest. However, for now, we're choosing to run them through the same vehicle as our transcript so that we don't have to build out additional functionality. Thanks for running through this with me. I'm happy to answer any additional questions that may come up, and I love to geek out about the Pres3 API. And we'll talk with anyone who's willing. With that, I'm going to hand it back to Adam to talk about some of the tools we used and maybe give some final thoughts.
Yeah, so kind of at everything, I guess Karen and Matt have shown thus far, just kind of how we're moving from version 2 to 3. So one might ask, what special tooling or packages are we using in this code and developing like against the 3.0 spec currently? So not a whole lot, actually, but one package in particular that we've found kind of helpful and would like to share in case others are interested is something called the Hyperion IIIF framework. So it's a JavaScript package intended for UI apps to help interact with IIIF manifests and basically break down like a manifest, potentially complex structure into a more easily reasoned format. So the Hyperion project, it's quite ambitious, and in our experience so far, definitely not yet feature complete, but it's on its way there and something that we might be excited to help contribute towards in the future. It's being led by Digirati's UI tech lead, Stephen Fraser, who does some really great IIIF front-end work. So how do we actually use Hyperion in our app? So we kind of use it to initially fetch a IIIF manifest. Hyperion then takes a snapshot of the manifest state, and it does a couple of things with it. One, it stores this in a Redux store, which could be helpful down the road, say if you had changing data states surrounding a IIIF manifest. So say you're like developing a IIIF manifest, like visual builder tool for a researcher to use or something to make it a little bit easier to work with building these out. A data state container for manifest data could be super useful on the front end. But back to how we're, I guess, using it at the current time. So we feed Hyperion a manifest URL. And then we get back from Hyperion a flattened out, normalized version of the manifest data. So data in this shape can definitely be more easily used in our app and saves hundreds, if not thousands of lines of validation code, protecting against maybe nulls or undefineds, depending on how much metadata we have represented in our manifest. So when using Hyperion, if you need to go like further or deeper and pull out like deeply nested manifest data, Hyperion provides this concept of, they call it a vault, where essentially you provide like an ID of the resource within the manifest that you need more data from, and then Hyperion gives you a flattened out version of that particular slice of data. So this may sound a bit confusing, just talking about without kind of seeing it in action. But after experimenting with the package, it definitely provides some nice patterns that Matt and I have found for extracting complex IIIF manifest data, and just makes it a little bit easier to write front-end code around that. And we think, IIIF JavaScript tools like this, especially ones like Hyperion, which ship with React bindings, are going to be highly influential in driving IIIF user interface development in the future. It just makes it easier. So final thoughts on kind of, I guess, where we're at. So again, this is pretty new for us. Most of the things that we've shown here have just happened in the past month. So it's a work in progress, but maybe that supports maybe our first final thought is, if anyone out there is considering the same, just start. When you're working with the spec and transitions and whatnot, it's totally okay to give yourself some room to experiment and, expect failure and know that that's okay. So say you're trying something new, call your code branch, throw me your way. That's totally fine to just approach it from that perspective and give yourself the flexibility to, learn where things fall down or discover use cases like we did that were probably impossible to predict before walking down the road a little bit. Sometimes you stumble through things and you learn, and then you revise, and you just keep it an iterative process. Another final thought, at least on the UI side of things, developing against a spec is really nice for the UI, and that's kind of what jump started, I guess, our transition from version 2 to 3, was just thinking about the best way to create a particular reusable UI component. So when you build anything reusable, what comes along for the ride is your own API detailing how other code is going to use your thing. So, we knew the IIIF data model could accurately capture what we were trying to do, or our data. And that's like building out some kind of viewer thing against the spec. That's just a whole lot of decisions, like naming conventions and labels and all the stuff that we don't have to make. We just get that for free from IIIF, which is awesome. And in fact, when we first started kind of playing around with this, Matt and I kind of half jokingly threw out an idea that maybe just on the front end alone, if we were going to support 3.0 or version 3 of the spec, maybe just on the fly, our front end code would just kind of create like a version 3 compliant manifest object that we could feed into this viewer thing, just so we could build to a spec. And then again, if our team's building to a spec, then hopefully that's something we can eventually, share back out to the community, or something that we can, jump back into another community package, combine work, now that we have our heads wrapped around working on this a little bit more. Maybe a third takeaway, it seems as more and more repository systems start representing their works through IIIF and try to push the boundaries of a particular version of the spec and try it against many different use cases. Ultimately, hopefully the presentation API from IIIF is going to become more resilient. So this will translate into an easier to use API for client front-end apps. And easy to use APIs really drives a broad, diverse, and creative body of UI implementations, which ultimately is going to benefit users. Us as developers, we can react more quickly to end users' ideas, their use cases, and ultimately, hopefully, meet their needs. So, I guess more info thanks to our other team members who have also, been working hard on this with us, David, Brendan, and Michael. And if folks are interested in kind of checking out what we're doing, again, it's a work in progress, but we're making headway. There's links to probably the three major repositories that you're going to see the code reflected on what we've been discussing today. And I think that's it. I don't know if there's any questions. Matt and Karen would be happy to answer.
Yes, and it looks like there are a couple questions in the Slack already. One, by normalized flat file, does that mean that it dereferences the links as well and puts it all into one file?
So normalization means, like, let's just say your manifest doesn't have a thumbnail associated with it. That the vault, Hyperion vault will take that and store it in a Redux store as an object, but it will add sort of an empty thumbnail property. So that property will exist. And what that'll do is it'll limit the chances of your front end app trying to retrieve that manifest and that thumbnail not being there and it falling down. Instead, it'll just, you can sort of write your code to be a little bit lighter so that you don't have to worry so much about whether those things are going to fall down.
Yeah, I'm sorry.
Go ahead.
Yeah, all the links should maintain their integrity, but I think it's for situations where you have like really maybe like thin metadata in your manifest. So say you only have like 2 fields like populated, you're going to get back something from Hyperion that could be like an object with all supported properties for whatever it's like the canvas or whatever part of the manifest it is. So you could have like an object with like 20 properties, even though you might only represent 2 in your particular manifest.
Okay, one more question, actually a 2-parter. Will this viewer be in Samvera Labs or otherwise done in a shareable way or custom to NU? And then when do you anticipate it being deployed production?
I guess we could all kind of answer that, but again, we're just kind of like working initial, like this viewer, we're initially just trying to work on it locally just to help kind of like prove out kind of our unique, I guess, like implementation or kind of to meet our very kind of specific like needs at the moment. But we're aware there's, some awesome work going on in the community regarding like IIIF like players and stuff. So I think ultimately, maybe we see this like down the road, hopefully not too far off, being able to put, our ideas, to share those with other similar kind of packages going on and maybe do some collaborative work and then kind of like shape that up a little bit. And then, yeah, hopefully it'd be nice to offer some kind of community package that a lot of people could get value from.
And I should say that the customizations for Northwestern right now is maybe limited to color. And all we need to do is then maybe extend it a way for someone to be able to configure a theme to adjust brand colors. Otherwise, it's pretty open. The only thing that the viewer expects is a valid Pres 3 manifest. And it assumes that those manifests are going to be somewhat multi-canvas. Otherwise, that tray that's below the media player is going to be empty, and it also assumes it's going to be supplementing BTTs. Otherwise, that area that's adjacent to the media player is going to be empty as well.
I just wanted to add that it is deployed to production. We just do not have AV content in production yet, but that should be in a couple months.